Hello everyone. Today we are going to solve the problem removal game. This is the 13th video from the DP series. Right. Let's try to solve it. So there is a list of 10 numbers and two players who move alternatively. On each move, a player removes either the first or the last number from the list, and their score increases by that number. Both players try to maximize their score. What is the maximum possible score for the first player when both players play optimally? Okay. So let's take the example. You have the four numbers, and the numbers are 4, 5, 1, and 3. Right. Now you can choose either the first element or the last element, and you have to delete it. So if let's say this is for player one score, and this is player two score, right? So initially there are two choices that you could choose the first element or you could choose the last element. So whatever, so player one choose the maximum number uh, that makes it score larger. So the maximum number is 4, right? And this number is going to be deleted. Now player 2 has these three numbers. It can choose either 5 or it can choose either 3. Player 2 also has to make maximum score. So it definitely choose 5. Now it choose 5. And this is also deleted. Now player 1 have choices between 1 and 3. So he definitely going to choose 3. And now next the number left it is 1. Right? The number left is 1. This is deleted. So player 2 going to choose 1. So score for this the score for player 1 is 7. The score of the player 2 is 6. Right? But this is not the maximum score that player 1 can have. Right? Let's we start with the maximum number. Right? Let's try to explore other possibilities. Let's try to explore other possibilities. So you have 4, 5, 1, 3. Right? Let's say this is the player 1 score. Right? And this is the player 2 score. Perfect. Now previously we started with the 4, right? We choose the first element. Let's try to choose 3, right? That is the last element. That is the other possibility. Now if player 1 choose 3, this is going to be deleted. The next choice is for player 2, that is 4 or 1, right? So let's try to choose 4, right? Let's try to take 4. Now this 4 1 is deleted. We left with the 5 1. Let's take 5. Then player 2 choose 1. So the score for player 1 would be 8 and this would be 5. So from 7 and 8, 8 is the maximum. So what we observe that? We observe that greedy greedy approach doesn't work, right? Greedy approach doesn't work. So what we have to do? We have to try all possibilities. We have to try explore all ways, right? So this is something that DP comes in my mind, right? That we have to try all ways, right? So there might be a sub problem that we have to. So this forced me to think in the DP direction. Now let's try to explore all possibilities, right? So you have 4, 5, 1, 3, right? Now let's try to make some observations, right? Let's try to make some observations. Right. Suppose you have only one element in the array, right? Suppose you have only one choice, that it might be a 4. Suppose it is 4. Now, what will be the maximum score player 1 can have? That is the element itself, right? So let's say score 1 denotes the score of player 1 and score 2 denotes the score of player 2. So the score of player 1 is good. Maximum score player 1 could have, that is 4, right? It definitely take the element if there is only one element, right? Now, what if there are two elements? Suppose 4 and 5. Now, if there are two elements, so it definitely takes a maximum, right? It definitely takes the 4 and it will be deleted. Score of player 2 would be 5. If it takes 5, if it takes 5, then player 2 would have 4. So the maximum score would could be 5, right? Now, what if you have three elements? That is 4, 5, 1, right? Now, if you choose first element, you left with the 4, 1, and definitely you take the maximum. So the maximum would be now if there are two elements, right? Now think about it. This is the previous problem that we have solved, right? That we have solved. Suppose it takes the last element, that is 1. Now 4, 5, it is the problem that we are already solved. That is answer for this is 5, right? Right, and for this the answer is 5, right? So the maximum score that uh, suppose it choose first 4, Then player B choose 1 and then it choose 5. The maximum score could be 9, right? The maximum score could be 9. If 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 it is choose 4, then we left with the 5 and 1, right? If player B, what player B choose? Player B definitely going to choose 5 because it is also plays optimally, right? So the score cannot be 9, right? This is something that you have that you have to care about. That if 4, if player choose the first element, so from 5 1, definitely the answer going to be maximum, and this is the answer for the player 2. Player 2, that is both plays optimally now. So why player 2 choose 1? It also choose the maximum that it has to be play optimally, that right? So it definitely choose 1. It definitely choose 5, right? And player 1 has to choose 1, right? So the maximum possible that it can have is 5, right? Perfect. Now what could be the observation that you could have? That player 1 can have 4, 1, and player 2 has 5. If let me write it correctly. So if 5 4 5 1, so if it is if player 1 choose the first element, the next, then the answer for this interval is the maximum, that is 5, right? This is for player 2 score, and this is for player 1. Then it has to choose 1, right? Now what if it choose 1? It choose 1. The next that player 2 choose 5, and for this it is left with 4, right? So one thing you have to notice that the score of player 1 and the score of player 2, the sum of the score is going to be the sum of the elements, right? Sum of the, suppose this is denoted by A, AI, right? Sum of the elements that you can have, right? Now, this is the first observation that I could make. Now, what is the next observation that you have? That is, you have uh, score 1, you have score 2, you have score 1, you have score 2. You have to minimize the score 1, you have to maximize the score 1. That is something that you have to do. Now, if you maximize the score 1, if you minimize the score 1, that is something that you have to maximize the difference, right? The difference, you are going to maximize the difference. So instead, so what is the optimal? If you found the maximum difference, if you are able to find the maximum difference, then you are able to find the maximum score for player 1, right? Now, how, suppose this is the case, right? So 4 plus 5 is equals to 9. That is score 1. That is S1 plus S2 is equals to the sum of the elements. Let's say we denote it with sum, right? Sum of the elements, right? Now, what will be the difference? The difference will be 5 minus 4, right? The difference between 5. Suppose if it has to choose 5, then the score 2 will be 5, and the difference it is going to be 1. This is something that is difference, right? Now try to, what is the answer? What is the answer? That is, difference is 1. Its difference is 1, right? So what will be the answer, right? What will be the answer for player 1? That is, what is the maximum possible score for player 1? If you have the maximum difference that is of 1, how could you find that? That is, if the total sum is sum, and you have the difference, the answer is nothing but the, try to solve this equation, that is it left, that is to S1 is equals to sum plus difference, and S1 is equals to sum plus difference by 2, right? This is the score of player 1, right? And this is something that you have to maximize. If you the the maximum difference gives you the optimal score for player 1, right? So next you have to find the maximum difference. Maximum maximum difference, right? Perfect. So for this, in this case, you have the total sum of 9 plus 1 divided by 2. It gives us 5, which is the score of player 1, right? Perfect. So we have two things, right? First, we have to maximize the difference, right? And the second thing, we are able to solve the smaller problem, that is, if there is only one element, if there is only two elements. So the answer for this, if there is only one element, so the maximum score that player one can achieve, that is the element itself, right? And if there are two elements, we have to take the maximum of element one of element two, right? So these are the observations that we made, right? Now, with the help of with the help of these two problems, let's try to solve for the next uh, bigger problem, right? So for 4, if I consider only the one element, that is 4 itself, that is 5 itself, that is 1 itself, that is 2 itself. So what will be the answer? The answer is the element itself, right? That is the maximum difference. I am talking about the maximum difference. It is the element itself, right? Uh, yes. So let's find out the side if we have the two elements, 4, 5, 5, 1, and 1, 2, right? Let's try to find out for this. So what will be the maximum difference? That is, and we have the answer for the player one. That is the maximum score that player one can achieve. It is the maximum among them. So S1 would be S5, S2 will be 4. So the maximum difference that you can achieve, that is of the absolute difference between the absolute difference between these two elements, right? The absolute difference between these two elements. So the maximum, what I'm trying to say, that player one can choose 5 or 4. If it is choose 5, the other player has to choose 4. If player 1 choose 5, the player 2 has to choose 4. And the difference between these two scores are 1. Right? If player 1 choose 4 and player 2 has to choose 5, the difference between these two, S1 minus S2 is minus 1. So you have to take the maximum of them, that is 1. So for all of the case, the maximum would be the absolute difference between these two if we have the two elements, right? So what is this? If we have two elements, the maximum difference would be absolute difference between element 1 minus element 2, right? So for this, the answer is 1, for this, the answer is 4, for this, the answer is 1. It is 3, right? It is 3. 1, 3. It is 3. So for this, the answer is 3, for this, the answer is 2, right? Perfect. Now I have to solve for the problem larger than this, that is of interval 4, 5, 1 and 5, 1, 3, right? So if you are going to take 4, you have two options, that you could take 4, the first element or the last element. So if you take 4, let's try to solve for 4, 5, 1, right? If you take 4, then the interval that you have to look for 5, 1. If you take 1, then you have to take the maximum of the interval of 4, 5. Now for 5, 1, the answer is 4, right? And for 4, 5, the answer is 1. What will be the maximum difference that you can achieve? If you take 4, 4 minus 4 is equals to 0. If you take 1, 1 minus 1, 1 minus, 1 second. If you take 4, the maximum difference is 4. If you take 1, you have to look for 4, 5, 4, 4. Yes, 0, right? 0. You have to take the maximum. You have to take the maximum, and the maximum is 0 itself. So for 4, 5, if you gonna to take 4, 4, 5, 1, the answer is 4. So the difference is 4 minus 4 is 0. If you take 1, so 1 minus, you have to look for 4, 5. For 4, 5, the answer is 1, right? So, and again, the difference is 0. So maximum difference for this can be 0. Now, if you take 5, then you have to look for 1, 3, 4, 1, 3, the 2. So 5 minus 2 is 3. And if you take 3, 4, 5, 1, the answer is 4. 3 minus, you're going to take 3, 4, 5, 1, the answer is 4. It is going to be minus 1. From 3 and minus 1, the maximum is 3. So you have to take 3, right? So you have to take 3. Perfect. So for the so for the 3 interval of 3, the answer is 3, 0, 3. Now let's take the 4, 5, 1, 3, right? So what you could do, you could take 3. So next you're going to look for interval of 3, 4, 5, 1, 3, the answer is 3. So 4 minus 3 is 1. If you're going to take 3, 4, 5, 1, 3, the answer is 0. So 3 minus 0 is 3. What is the maximum? Maximum is 1, maximum is 3. What is the maximum difference? Would be 3. So we found the maximum difference, that is 3. So what will be the answer? 3 plus total sum is 30 divided by 2. 16 by 2, answer is 80. Right? This is something, this is how you could solve your problem. Right? Now let's try to define DP state. We have to, the observation that I could make, that if you are at the place, if you choose the last element, if you choose the first element, that is, let's take the interval LR. You can choose the R, you can choose the, you can choose the L, you can choose the R. Right? So if you take the L, if you take L, so let me define first DP state. Let me define DP state. Yes. So dp of something LR interval, for the interval LR, is defined as the maximum difference in the interval LR, right? LR, maximum difference in the interval LR, right? So what you what choices that you have? You can choose the first element, that is the L, right? That is the AL, or you can choose the last element, that is the AL. So dp of L, dp of L minus, you have to, you can choose this or you can choose this, right? Now, what will be the difference? If you choose 4, 5, if you choose 4, then you have to look for this interval, that is L plus 1 R, right? And you have to minus to take the difference, dp of L plus 1 R, right? And for this, if you choose 3, then you have to look for this interval, that is R minus 1, L R minus 1. So minus dp of L R minus 1. This is the interval. And you have to take the maximum difference among them, right? This is the transition state. Perfect. So we have the transition states. We have the transition state, that is dp of LR is equals to maximum of dp of L minus with dp of L plus 1 R, right? If I'm going to take the left, that is the first element. If I'm going to take the last element, then I have to look for interval R minus 1, right? And dp of ij represents the maximum difference in the interval LR, right? What will be the base case? I discussed it, right? That is, if L equals to R, that is, it has the one element, then dp of LR is equals to the element itself, or R, right? This is the base case, right? And this is the transition state. Okay. Now, perfect. This is the base case. This is the transition state. One thing. Now let's try to code it. We have n number of elements, C in n, right? And let's define the vector of int a, well, for int I is equals to I less than n, I plus plus C in a. This is our input. Now let's define the dp vector. The vector of long we have to define it is of type long dp n comma vector long of size n close n, right? This is our dp vector. Next we have to traverse from L equals to n minus 1 and L is greater than equal to 0, L minus minus. Why L goes from n minus 1 to 0? Because we saw that if we take the first element, the next the interval that we have to looking for the L plus 1 R, right? So for L plus 1, it means that this stage depends on the next. So we have to traverse from n minus 1 to 0. Now for R goes from L to n, right? R is equals to L. Perfect. Now, what is our base case? That is, if L equals to R, then we have to, that means there is only one element present, and for this the answer is the element itself. Perfect. Now, else we have to do the transition, that is dp of LR is equals to max of, right? If we take the first element minus dp of L plus 1 R, this is the interval, right? This is the interval. If we are take the first element, if we take the last element, then we have to minus it with dp of L R minus 1, right? This is the interval. If we take the
last element. Perfect. Now this is our transition state, right? Now the next thing we have to do, that is construct our answer, right? For this we have to take the sum equals to accumulate a dot begin comma a dot end comma 0 ll. We have to take it long, right? Long loop, right? Now let's take the maximum difference. What is the final problem? That is the maximum difference in the interval of 0 to n, right? So the maximum difference from 0 to n minus 1 interval, right? This is our maximum difference, and we have to print our answer, that is sum plus max difference by 2. This is our final answer, right? So this is the whole code. Let me check it once. We take the inputs correctly. We we construct the maximum sum, then we define the dp vector, then we write the loops. This is our base case, this is our transition, l plus 1 r plus 1, perfect. This is our final answer. So let's try to run it. I hope it's run successfully. No, it's not. TP, it's TP. Perfect. Now it has to run successfully. Yes, the answer is 8, right? So the time complexity is going to be, what is the time complexity? That is n square, right? That is n square, right? The first loop goes from 0 to n minus 1, then it goes from 0 l to n, right? R equals to l to n, and l goes from 0 to n. So the final complexity is going to be n square, right? And the space we are using the 2 divided of n cross n, right? So this is the code. I hope you understood it. If it is not, comment it down. I try to resolve your doubts, right? Thank you.